I'll find one of those for us to use. Zoom this out. Zoom this out. Yeah, I'm totally seeing where this is going to go with here. I can't see past data. How would you guys feel about that? Like one quick estimation on the take home, and then just a bunch of this kind of stuff. Decent? What do you like better? What do you feel more comfortable doing? This or the estimation? What do you think?
This.
A little of both? Well, that's why I'm going to try to make the exams a little of both. I'm thinking for the take home though, we can really run with this. So who says estimation? We've had a dig estimation. A couple of you dig the grade a little bit more. That's maybe 3 or 4 times as many. A couple of you thinking about the same? About the same, we like them both kind of the same? Roughly this, okay. So it looks like the grade's a little more democratically popular. Probably because it's less unknown. It's based off of data we've collected. That kind of makes sense. Yeah, I'm thinking I might make some more grade stuff on the take home just because you'll have the time to kind of stretch it out. Anyway, we need a tangent table. We found one of these last time, didn't we? Ugh.
Saw that.
Did I have it linked on your homework page? I probably did, didn't I?
No.
I didn't? What a bastard I am. This will probably be good enough for. Can you guys read it okay?
It's not bad.
Now there's too much information. Sine and cosine, I don't want that. You know what? To hell with that. Yes, let's use that one. I'll show you why in a second. Control plus, control plus, control plus. Okay. So what you've got is you've got sine, tangent. Ignore all of it except for tangent right now. What angle am I running? Nick gave us this answer a while ago. But what angle am I running at if I'm running at an average grade of 16%?
9-ish, 10.
Yeah, so here's 15.8%, and there's 17.6. I think it's closer to this guy, so somewhere right above 9 degrees. Somewhere right above 9 degrees. There's my grade, if you will. So that's like College Way. No, it's deeper than College Way. That's like, how road was that? Galabert Pass, maybe one of those Tour de France roads. I can't remember exactly. So, here's why it doesn't matter. This is actually a cool mathematics. Everybody okay with how to use a tangent table to calculate that?
Yes.
There's also a ratio, because a tangent in mathematics is the same thing as grade. It's rise over run. Do you notice how close these numbers are to these numbers here? 15.1584.1564. The sine, S-I-N-E, this is going a little bit outside the scope of Math 105, but I think you can understand this. The sine is like the grade, but instead of grade being rise over run, the sine is rise over hypotenuse. And that's where we got over there. So technically, we didn't do the grade the first time around, we did the sine. And what we just showed was, for certain values of an angle, the sine and the tangent are essentially the exact same thing. Essentially. Now look what happens as you start going down. As we start getting low, like down at the bottom, look, they're equal to 4 decimals. At 1 degree, they're equal. At 2 degrees, they're equal. At 3 degrees, they're off by 1,000th. That's not off at all. Then they start getting more and more off, more and more off, more and more off, more and more off, and then by the time you get down close to 45 degrees, tangent is 1, sine is 0.7. That's significantly different. That's significantly different. Not by different to 30%. But for a while up there, the sines and the tangents are essentially the same thing. So, if your angle is small enough, and when I say small enough, I mean any angle that you're ever going to be driving on in a car, unless you do those crazy off-road things like down in Moab where you're blowing out your oil pans on rock formations, maybe. But if you're driving on an interstate highway or a state highway, you're not going more than 6, 7, 8% grades on those things, right? Anybody ever seen a sign on an Oregon road that says more than 6% grade? You may have, I haven't, but has anybody seen them?
Yeah.
Are there any 7s or 8s? There are some.
There's 11.
There's an 11. Where's that one?
I think that was the one that when we were, I was 5, on 5 when you're going down.
11%. Holy crap. Well, let's look. 11%. Look though. Check this out. Even at 11, no, 11%. Sorry, 11%'s here. 11%. Closer to these, I guess. 10.5, 10.5. Essentially, you can treat the hypotenuse like the run, and it's not going to affect our answer all that much. So essentially, when you get anywhere up here, and we'll analyze this more carefully, but for right now, I mean you've got it. I mean that's the idea. You're close enough with the hypotenuse, which means we can ignore Pythagoras for slight angles. You can't ignore hypotenuse at Pythagoras for things like ADA ramps. Because that angle was actually very steep, if I remember correctly. I think the grade was 28%. 28%, so we're getting down into this range now. We're getting down into this range now, which means we're talking about angles that are 16, 17 degrees. And you can't be off because lawsuits might depend on that measurement, right? That's what you don't. That's when precision becomes much more important than convenience. Yeah? Yeah? All right. I had some other stuff planned. We're not going to do it because you look worked. Ariel, I cannot thank you enough for asking for that question. I apologize for taking it and going willy-nilly with it. But I think we just wrote 2/3 to 3/4 of your next take-home exam because of this problem. I mean, I think we can apply this to the McKenzie Pass, and I think you're going to be all over it. I think I might make this your next quiz, this kind of thing, your next quiz for next week. My afternoon is booked. I'm looking forward to this. I'm looking forward to this already. You guys, we're going to take off. If anybody's got more questions, I'll stick around if you've got them. Otherwise, have a great weekend.